The next topic goes dear to my heart. I think FinOps, preventative FinOps is actually a really, really hot topic at the moment. I think in all of the sessions, anybody is talking about the shift left. So I'm really happy to announce Andrew and Greg from JPMC to talk us a bit more about shifting left, computer optimization, and tackling anomaly detection. Can I get a warm applause for Greg and Andrew?
All right. Hi, everybody. I'm going to start first, and then Craig's going to jump in. He's really, I think, while you're all here, right, because he's going to talk about computer optimization and anomaly detection. But I was really glad to hear, right, shift left was talked about a lot of times. It's not just something you should think about doing, right? It's a key ingredient, and that's why it's part of this presentation. And we're going to talk a little bit about how we are shifting left, and then go into some of the great work that's been done around cost optimization and anomaly detection. All right? So a little bit about JPMC. 63,000 technologists, right? A lot of technologists all over the world, thousands of apps all over the world, with developers all over the world, right? So massive scale. We have lots of cloud providers, public cloud providers. We have our own data centers. We have a lot of hybrid apps. Pretty much any combination permutation you can think of, we have. We do have a very large community of interest. Right? So we have lots of folks doing FinOps. We have 450 plus certified professionals, another few hundred in the making. It's pretty small, though, compared to 63,000 folks, right? So getting folks certified is very important to get the language of the cloud, language of FinOps, right, ingrained in. And we also use that COI to share best practices, share our problems. Don't underestimate the power of a COI that could do for you, right? And then we're organized. We have a central team. Me and Craig are part of that central team. And then we have FinOps leads in each of the LOBs, right? There's probably a couple of hundred folks across the whole firm, something like that, that are doing FinOps. All right.
What's the certification count now?
It's over 450 and growing still. We put a lot of emphasis on doing certification. But the key thing is having folks out there to be ambassadors, right? So the right number for your organization will depend on your org. But it's something that's definitely part, and I'll talk a little bit more about that a little later. All right, go to the next one. So shift left. So what does shift left mean, right? So do FinOps earlier in the process. It also means doing things that prevent waste, right? Being proactive. And the more you can do that, it boils down to your developer efficiency. Something they can do in 15 seconds in a shift left versus 2 to 3 hours, it's not a business case to even think about. But once you make it a business case, oh, I got an email, $500 opportunity, it's going to take me 2 to 3 hours. Maybe I'll do something else. You lost them, right? So, when I talked about anomaly detection, computer optimization, they get these emails, they might start ignoring them. That's the risk, right? So what can you do? So the things listed here, I'm not going to go through all of them, are things that our developers should be doing as part of how they operate. So what I would ask you to do is go learn how your developers do their day job. Because once you do that, you can figure out where to put all those things that you want to do for FinOps into their daily BAU type of activities, right? So I'll give you an example. So we use blueprints. There's probably 5 blueprints all developers kind of use to get started. Microservices, machine learning, data lake, data processing, web apps. Probably want to build one of those things. So what we did was created a site. You go in, you find, let's say I want a microservice, it runs on EKS, on AWS. You download it, you start developing. But we put in there Spot, use of Graviton, night and evening shut off, so on and so forth. So they just get it out of the box without even thinking about it, right? You don't have to go clean it up. They're already doing it. Yes, they can configure it and change some things, but you can then, later on, scan repos and see what's going on. Maybe they took out all their night and weekend shutoffs. You can create a recipe and send them a PR request and say, please add it back in, right? So to scale at the level we're at, this is how you have to get things going so that you don't impact your developer efficiency, right? Plus, you can report on it. You know who's doing what. It's not just sending emails and things like that. So, a lot of things around tagging and making sure everything's tagged, right? Obviously, if you can do that, you don't have to go clean it up later. And the key thing around this whole thing is back to kind of FinOps 101, that spend, measure, learn cycle. If you can get developers to own their spend because they're doing all the right things, and that spend, measure, learn cycles may be a few days, right? Great things will happen because they will see things going on. The anomaly detection that Craig's going to talk about, don't just stop at building a great anomaly detection tool. Get it integrated into with your SRE teams, right? So that it creates a ticket, a certain severity, so they're going to track it down. Because one thing with an anomaly is you don't know if it's good or bad. You don't have the context, right? The SRE teams do. And me and Craig would spend a lot of time trying to find people to solve anomalies over the weekend, right? That's not what we really want to be doing, especially over holiday weekends, right? So, and they do happen, but we don't know if they're good or bad, right? So you get them integrated into how you operate. So back to spend, measure, learn real quick. That's about FinOps 101, owning your cloud spend. And the quicker that developers are seeing what's going on and taking action, right, you don't have to really worry about it anymore. Right? You don't want to be the FinOps scorecarding police, so to speak, right? All right, so Craig's now going to get into why I think you're all here. So I'm going to leave it to him to take you into the details.
Right, yeah, so when Andrew asked me to put a couple of topics together to come talk to you about, the two natural ones were compute optimization, because like optimizing EC2 makes a lot of sense for us right now, given our spend in that space, and also anomaly detection. So I was going to do a quick show of hands on those two topics. Who's more interested in compute optimization? Not very many, a few, okay, and then anomaly detection? All right, it looks like anomaly detection wins out. I'm going to run through compute optimization real quick, just because I spent a lot of time on the slide. And then we'll get into anomaly detection. All right, so compute optimization challenges, obviously you already know all of these. They're particularly an issue for us because we've had to move a lot of legacy applications from on-prem data centers where they're already running on virtual machines up to the public cloud where they're now running on EC2, right? So for many of these applications, it doesn't make sense to spend the time in containerizing. And so we just have to live with the fact that they're running on EC2, and we know that there's a lot of inherent issues like around oversizing, et cetera, underutilization on that platform. So that's the first part of the challenge. The second part of the challenge is, you probably already know, just getting traction with the application teams. They're the ones that need to make the changes to their Terraform code or however they're pushing the infrastructure to the cloud to actually get the changes made, okay? So those are the two issues that we're really trying to tackle here. The way that we tackle it at JPM, it's largely a scorecard-driven process at the moment, okay? So we know we have the option as well of doing automated right-sizing. We do a little bit of that on-prem at the moment, but to be honest, we're not quite at the maturity yet where we're willing to kind of trust that in the public cloud. So right now, what we're doing is gathering a lot of utilization metrics, putting them together on a scorecard, and trying to drive change through reporting. So as we call out there, it's a sort of measure, score, report, repeat, sort of a cycle. This is, again, just a representative. This is not the actual report that we use. This is something I knocked together in Excel real quick. I'm going to call out some of the attributes on here that may not be all that obvious to everybody. Some of them I think are fairly self-explanatory, but some of the really important ones I think that are good to look at are the idle time cost. So basically, for every instance that's out there, you can measure how much time it's spent idle, and you know what the hourly rate is for those instances. You can pretty quickly figure out what the idle time cost is for an entire fleet, roll that up to a particular application, and then call that out at a monthly level to say, look, we think you've got this sort of usage that's idle. And obviously, there's always going to be some idle time. We're not saying people should have zero idle time, but it's good to understand what the relative differences are across some of the bigger applications. Because if they've got big, heavy servers that are idle, then that's something you want to call out. You can also use the native tooling. For example, on AWS, we have Compute Optimizer and Trusted Advisor. So if you take those recommendations together, you can kind of roll those recommendations up and total it on up and kind of call those out as well. The spot market usage is kind of self-explanatory. The daily population variance may not be a very obvious one. So that's like a measure of the elasticity that the application has. How well are they scaling, either on a daily level or on a weekly level? Are they shutting down at the weekends, for example, in lower environments? Are they scaling up and down as a matter of their normal course? Right, so that's another pretty good one to look at. Modern instance types, I think that's pretty self-explanatory. The one that's probably requires the most explanation is around compute capacity utilization. But again, we won't get into that now. If there's more interest in the anomaly detection stuff, I'll kind of skip over that. But yeah, we can talk about it afterwards if anyone's interested in learning more about that. I'd included the first two columns there around mean average CPU and max CPU, just as a kind of a counter example. I don't really think those are very valuable to look at, mostly because unless you're using some form of weighted averages, then you're not really taking those instance size differences into account and how long those instances are running. That should all be part of some sort of weighted system where you put a lot more emphasis on the expensive servers, how how well utilized are those big, heavy boxes that are running for long periods of time. Those are the ones that should get more of a weighting on your dashboard. So I would probably drop the average, simple average CPU, because what you have there is an average of the hourly CPU, averaged over the life of the box, averaged over the entire fleet that belongs to each application. So it's an average of an average of an average. It's not really a useful metric. So I would skip those two columns and focus on some form of compute capacity utilization instead. And if you can distill it all down to a single number, whatever algorithm you want to use, whatever makes sense for your context, get some sort of an overall score metric at the end so that you can sort the applications, by that one metric. The good applications will naturally sort of tend towards the higher scores. Here we just use in this example like a simple rate of 1 to 10 range. The way I recommend doing the scoring on this, once you figure out which attributes you want to include in your calculation, is you should use some sort of quintile-based system, right? Don't use absolute ranges where you say, we want your utilization level to be, in this particular range. So use quintiling instead. So with quintiling, what you do is you take all of the applications you have in your estate and you divide them into equal size buckets. So that the bottom 20% of applications for a particular metric go in the bottom bucket, the top 20% go in the top bucket, they get scored, and everything in between gets like some score in that range, and you total all that up and figure out what the overall score is for the application. This allows you then to roll this up. So an entire LOB can be rolled up to the point where you get the average score for a particular LOB head. And that means then all of your heads of those lines of business or departments, they can kind of be compared with each other, and you can get a bit of friendly rivalry going there. And when those CEOs need to sit down with the heads of the departments and have those conversations around, why are you guys last on the list? That's where the interest starts to drive back down to the application teams again to see if we can make any difference there, right? That's a good way of getting traction with the application teams, because now they're all aware of the fact that senior management is very interested in this space. And when that awareness starts to build within the application community, they realize that they need to start taking some changes into account on the sizing of their instances. And they're kind of confronted with the level of waste. If you're called out as being in the bottom 20% on every metric on the dashboard, it's time to start taking action on that, right? So that's kind of the principle here. And that last point, I think, is the most salient one. It's not really about the dashboard. It's more about raising the awareness of the fact that this is important for the organization. The amount of spend that we have in this area is, again, very significant. We know there's a lot of waste that's inherent in the estate here, so it's certainly worth chasing. Okay. That's pretty much it for compute optimization. So I'll move on to unless you had something to add on.
I was just going to add, one of the things that's really useful for is, let's say I have an app that has 500 servers, right? And they have like 5 optimization opportunities. They're going to score a 9 or a 10. Not a problem, right? Maybe I have an app that has 10 servers and they're scoring a 3, right? You have a more systemic problem with that team, right? So it really highlights where to go, because individual recommendations, right, you get lots of them, right, don't really tell the story. It gives you that context overall for the app, right? So if you have one line of business that's a lot of 8, 9s, and 10s, they're doing pretty well, they don't need any help, versus another group maybe has lots of 3s and 4s, they probably need more help. Right? It's not the total number of recommendations you're getting. It's really that whole application picture that you really want to talk about, because you may need to educate them more, or whatever you need to do to get them on track. And it really highlights that, rather than just looking at thousands of recommendations without that context.
Yeah, exactly. Yeah. So kind of the percentage of the recommendation as a percentage of overall spend is kind of important there. Yeah, exactly. Okay, cool. All right, so I'll move on to the anomaly detection stuff, so we can spend a bit more time on that, and then we'll have one more topic to cover, I think, towards the end, and then we'll open up for Q&A to give plenty of time on that. Okay. So, spend pattern anomaly detection. All right, so you probably already know why this is an issue. For us, with thousands of application teams using the cloud, even if everybody is very careful, every now and then, like black swan events occur, something goes wrong, spend can go off the rails very, very quickly. Right? We don't put guardrails on each account intentionally, because we leave it up to each application team to be responsible with what they're deploying to the cloud. And in most cases, it works out just fine. But again, it's a numbers game, right? So you have a lot of accounts. You're going to have every now and then, unfortunately, some sort of event that needs to be caught quickly and brought to the right people's attention so that they can do something about it. Okay? Again, it's a very decentralized engineering model at JP. And we like that because it really improves innovation and helps things to move very quickly, which is what we're all about on the public cloud. What we found is that the native anomaly detection tooling is good, but it needs to be configured within each of the accounts. And again, our model is that every application that we have at JP has its own set of accounts, usually for each individual environment. They'll have like a dev, test, and production environment, for example. It's a lot of accounts to monitor, and so you'd have to set up anomaly detection on each of these accounts individually, which is not something that's going to scale very well. So what we have to do is basically roll our own anomaly detection system that can look across all of the accounts and then alert the right people when something happens. All right, so I'll explain a little bit about how that works. One of the issues that we honestly have not managed to tackle is around this billing lag. So we have like an inherent 24 to 48 hour delay in when we get the billing data from our CSP. That's as fast as we can react to it then. That is, that does allow enough time for spend to go, quite bad over the course of the 24 to 48 hours. It would be better to catch it within a few hours if we could, so that we could take action before things go bad. But, at least catching it in a day or two is better than at the end of the month or the end of the quarter, worst case, right? And then the last point there, this is also actually a bigger challenge than just the anomaly detection. So the title there says anomaly detection. That's not really the challenge. Anomaly detection, like mathematically, is fairly trivial. The complication is actually knowing who to notify, when to notify them, when is an event worthy of notifying an application team so that they'll, set up and take action. Okay, so we'll get on to a little bit of what we're doing around notification at the moment. It's not perfect yet, but we'll cover what we're doing there. All right. So our approach, as I mentioned, we developed an in-house system for this. We actually take two different approaches. One is what I call a micro forecasting or model-based approach, where we look at historical spend on each account at the service level and build up a library of micro forecasts, sort of day ahead, 2 days ahead, where we know when the spend is supposed to land within that time frame. Okay, we're not doing month ahead or year ahead forecasting, nothing fancy like that. This is not about financial forecasting. This is about setting expectations. What is the expected range for each of these spend levels to come in at? And then when the actual lands, then we'll know, whether or not it's outside of the expected zone. Okay, I'll get into that in a second. The second part is the population outlier. In this case, we're using our size to our advantage. So we have thousands of accounts. We might as well use them to figure out which ones are the outliers in that population set. It's a lot of accounts. We can just use them as kind of its own inherent, like, self-referencing system. When we analyze that on a scatter chart, for example, you can immediately see where the majority of accounts are clustered in terms of their spend from a dollar perspective and a percentage spend perspective. Okay, so I'll show you some examples of that in a second as well. I've seen a lot of cases here at this event where people are talking about that first method, so we're looking at model-based detection. I haven't seen too many folks using outlier-based detection, but I'll try and convince you that it's actually a pretty good idea that you should be doing that as well, because there are some anomaly types that will escape detection from simple model-based forecasts. Okay, and then the advantage of rolling our own means that we can integrate the resulting communications back into our on-prem reporting systems as well, our showback systems, right? So we can immediately link back to, let's say a pre-canned report that shows all the context that a team needs to have so they can understand the anomaly event in all its detail, all the context around it, the history of spend, the other service spend on that account, et cetera, right? And like I said before, we haven't yet fixed the billing lag problem. I think the one thing that will help us here is if you're in AWS land, the Cur 2.0, I think that's supposed to reduce the overall lag on the billing, so hopefully that'll help us react a little bit faster to this stuff. The other thing that could help us here in the future is not using the cost billing data to react or to find anomaly events, but start to really look at like CloudTrail events, maybe other event logs to figure out when, like say, an unusual number of lambdas have spun up all of a sudden. Like catch that and report on that. Don't wait for the billing data to come in 2 days later. You already know that if the number of EC2s on an account has spun way out of its normal range, that's worth alerting somebody to. Okay? All right. So in terms of the two models, what did they look like when we actually present them? How do you think about them, right? So the top chart there is the model-based forecast detection approach. So the blue highlighted area is the normal range for spend for that specific account and that specific service usage combination. So take, for example, in EC2, right? In EC2, the service, there's multiple usage types within that. Run services is one, EBS volumes is another. You want to really analyze each of those usage types separately so that you can dive inside the service detail to understand what's going on within the service. For example, in CloudWatch logging, you don't just want to know about the put log events, but you also want to distinguish those from, I don't know, read log and events of different kinds, right? So it's good to understand the different patterns within the service itself. And what we do in the report then, we can actually show how those individual services relate to the other services in that account. Again, it's a very account-based view. The way we create these forecasts is every day we analyze the historical spend on thousands of accounts and all the services within those accounts and create all of these forecasts. So we create using the open source Profit library, if you've heard of that. It's from Meta Labs, right? So that allows you to do time series based forecasts pretty accurately, especially just a few days ahead. It understands seasonality, so it's day of the week aware. It understands things like normal cycles in holidays, for example, so it has a holiday calendar built in. It's pretty good at understanding how spend relates to individual days of the week, so it can create pretty detailed forecasts and knows where the spend is supposed to land on any given day. And particularly when you're talking about a day ahead, 2 days ahead, it actually gets really good at kind of predicting what that range is supposed to look like. So you can immediately spot significant outliers. And by significant outliers, that definition probably changes from team to team where they have their own tolerance at. So our reporting system allows different teams to specify what tolerance they want to have outside of that range. So for example, a team that's quite small might have a $200 tolerance. A larger team might say, hey, look, we don't care about anything unless it's like $5,000 outside of the normal daily spend, right? So that gives some flexibility to our reporting then. So what we do is we work through a series of reports that have been defined over time by the FinOps teams across the organization. They each know which accounts they're interested in reporting on and what their threshold is within those accounts. Okay, so that's it for model-based forecasting. It's obviously daily based, so we do want to get down to that level of granularity. I think obviously monthly is way too slow. Hourly, there's just too much data there, to be honest, and there's too much noise in the hourly data, so daily for me seems like the happy medium in terms of reporting. Yeah.
Hey, and just one thing, right?
Yeah.
So on the forecast one, that's a spike, but you obviously can have other versions of this, right? We've had some that are slow, steady increases, and those are a little harder to catch because you don't break out of that blue line so fast, but then when you do, you kind of see a consistent trend, right? So don't think all this is just a spike. It can be any permutation of any possible line change, right? And the visual, immediately, you don't need any Excel reporting. You just look at that and say something's up, right? And relative to the other services in my account, I gotta go see what's going on. Was it an unplanned test? Maybe there's something going on I don't know about. But everything Craig's saying, it's about finding the right people, getting it into those ticketing systems or whatever, so it can be escalated, so you can get an answer.
Yep.
Right? Because I know. Oops, sorry. Me at JP, I get rated on how's the impact of all the work we're doing, which is financial. Could be related. This could be an outage that's going on, right? It isn't just about finding the anomaly, and I think that's a very, very key ingredient to making sure that you get credit for all the great work you do, right? Talking about the money is great, but it could be something else, right? I think we was talking a little earlier this morning about the whole framework. It's just taking it all the way to the end, right? Don't just stop at anomaly detection saying, here's an email.
Yep. Thanks, yeah. Yeah, I mean, to Andrew's point, we kind of divide anomalies into two different types. You kind of have your acute anomalies, which are the sudden, massive departures from the normal range. And then you have your more chronic anomalies, which are sort of this gradual straying off the path, right? And the problem with those chronic ones is any kind of model-based forecasting will gradually correct with those. And so it's possible if some spend gradually grows over time to some completely unrealistic or unreasonable level, that won't get caught with model-based forecasting. So that's where the second type of forecasting comes in, or anomaly detection rather. This is the population outlier detection that I talked about a minute ago, right? So when you have literally thousands of accounts, you can use that size to your advantage, like I said. And so it quickly becomes apparent when you do something like the isolation for a statistical model, for example. You can immediately see where your mathematical outliers are from any given population of accounts, where the norm is defined, right? So what we do is, we lost the scale on that chart, unfortunately, but what we have is up the side there on the left, I'm not sure where that went, but it's dollars on the left axis, on the y-axis, and then basically percentage of spend on that account on the x-axis, if that makes sense, okay? So you're kind of comparing those two things. This is not a time-based chart, right? So I'll explain that one more time. You're trying to basically picture the scatter chart where you have dollars on the x-axis and then percentage of spend on the account over, let's say, the 7-day period on the y-axis. And that allows you to immediately see what's going on. Yep. All right, so outliers should become immediately apparent visually, and then mathematically you can figure out what they are too, and figure out which ones are, again, within your threshold period, right? So our reporting, our daily reporting, looks at a combination of both the model-based and the outlier-based and comes up with a summary of those things, which goes out to the FinOps teams across the firm. There's a summary part at the top of the email that has kind of a quick view on all the breakdown, and then the actual detailed views, like these charts that are shown here, are shown below that to really get into the context. And then, as I mentioned, we have deep links that go back to our firm's reporting system on cloud spend, so people can go investigate things a little bit more if they need to. All right, we found this to be a really effective way of identifying anomalies in both spaces, okay? A good example for the bottom one there, that would be like a logging example, where like the logging spend on an account kind of gradually builds up over time to the point where like 90% of the spend on the account is on logging. We've probably all seen those examples. Like that's not something, if it happens gradually, that's going to trigger any model-based alerts, because the model forecast is just going to gradually grow with that and it thinks everything is completely normal. When you look at it from an outlier lens, though, you realize that, okay, nobody else in the firm is spending 90% of their weekly spend on logging, for example. It's completely disproportionate to their compute, storage, and database spend, for example. So that's why it's a super valuable combination of things to look at. Okay?
All right.
Yep. And I go on to the last one.
Yep. All right, so JR mentioned this morning, right? FinOps is a culture change, right? So you need that as a good foundation to actually have all these conversations and get people to care about their daily spend and care about this stuff, right? So that's still super important in all this. And one way you do that is through education, right? We talked earlier a little bit. Getting folks certified, learning the language of FinOps is really key, but also doing a lot of hands-on stuff, right? It's not just about getting certified or watching some videos. Actually get people in a room and actually tell them how to like do weekend scheduling, right? Turn off nights, like actually do it with them, right? Because once they do it, they can show others. And we do a lot of that. And then the community of practice is really key, right? So don't underestimate how powerful that could be, because a lot of people are doing stuff, even just to compare notes. What everybody's doing is key, right? We found lots of tools out there. We bring them into the center, make it available for everybody. And it really leads to everybody working together to solve problems, right? You don't have 5 groups doing anomaly detection on their own, right? You can kind of come together because you just may not know. And then really it's about what is your path forward in this space? What are your biggest problems, right? And then what's the saying, right? If you want to run fast, you go alone. If you want to run far, you go as a village, right? I think it perfectly applies with this, because I would say we've gotten way more out of our community of interest than I ever thought we could. Right? Next one. Yep. And then, lastly, right, you heard, avoiding whack-a-mole. You're going to have to do it. What I would ask is, and I'll give you an example, right? So we found a whole bunch of accounts that were quote-unquote dormant, right? They're supposed to be shut down, and they weren't, right? The script that ran to clean them out, shut everything down, kind of failed somewhere in the middle, and we found them, we cleaned it up. But what you do then is you go and you find the team that owns that script and that process, and you make sure that they have some kind of error checking going on, right? So you don't have to do this again, right? It sounds like SRE a lot, right? Where you would try to stop doing toil, but it really is important to continue and try to make these things automated, self-sufficient, right? It isn't just about fixing the problem. Yes, it's important to fix it, but your strategy shouldn't be, whack-a-mole is how we're going to do everything, because you're going to lose out. And then one of the things that I spend most of my time doing is connecting the dots across the organization, right? I meet with product owners, architects, engineers. They have councils and boards, right? This last reInvent, Werner Vogel spoke about, the frugal architect. First time ever, I think it got center stage. Once people know it's important, right? Top down, yes, that should happen too. But once you connect with people that this is important, you have to consider cost. Be efficient from the start, right? Be proactive about it. It goes a long way. People can't forget it. Right? And like I said, following through with everything, not just solve this problem, but solve it in a way it's consistent. It's not whack-a-mole. Will really go a long way, because that spend, measure, learn cycle is really crucial. Once you get people doing that, you can relax a little bit, because people have their eyes on it. It's not just me and Craig in the center, watching anomaly reports and chasing down people, right? All right?
Yeah.
I think that's a wrap. So you have some time for questions?
I'm sure there are no questions. No? All right.
I'll run.
Can you catch it? There you go. Almost. Keep it close, yeah.
Hello. So I work with FISO.
Okay.
Can you hear me?
It's not on this one.
Hello. So I work with FISO, and a lot of our business units are somewhat same like JPMC. I work with FIG, Financial Institution Group, and one of the situations what we have here is my QA team, when I reach out to them and say, okay, turn off when you're not working. They say, our QA team work with MasterCard, Visa, and a lot of other entities with their QA team for checks and balances kind of thing. So we cannot turn it off. So I'm sure your team may be having the similar situation. So how do you deal with those kind of things where you cannot put the lights on, light off scripts?
Yeah, so we ask each team, we do a say-do. Thank you. So we ask each team to tell us what can they do, and then we track them to that, right? So some teams can do 50% of the time, right? Because there may be just a team in the US, right? Or maybe there's a global team that's all over the world, they can't do it at all. So we just ask them, tell us what you can do, and we're going to track you to that, right? It is, somewhat dependent on the type of app, what's going on, but I think generally most people can do something. And the ones that do zero, you got to, or if they do 5% or 10%, you just need to understand it. And I think feedback loops are really important in all this stuff, because if you don't have a feedback loop, you just don't know why they're at zero, right? And then you can actually go maybe to the leadership of that team saying, well, this app's at zero because they have, they can't ever shut it off. It gets the FinOps team out of the loop, right? You don't want to be in the middle of those conversations.
Got a question over here?
Hey, thank you for the presentation. It was pretty awesome. I really liked the Excel snapshot with all the metrics in it. So I wanted to ask you, how long has it taken you to come to this point? Like how many years? And how do you ensure that the person, like an engineer who joins day one, like how does he get to know about FinOps? Or does he?
Do you want to do the second one first?
Yeah, so I would say we have a pretty good structure set up, right? So we have a whole site. We have a site it's an engineering website that has tons of information on it, right? We actually have so that they can go read all about all kinds of stuff, right, without having to talk to anybody. The second thing we do for everybody who's interested in FinOps, we have a monthly forum. And I think we're 1,000+ invites on there where people can come and hear what's the latest. And we cover things like what are the latest optimization opportunities, what's new, what do you need to worry about, right? And we have also like chat channels, people ask questions, right? So we make all of us very available to meet with people, talk to people. If an app team wants us to come and do a deep dive, we're happy to do that. So we try to make it as easy as possible to connect, which I think is key. And it also helps that the individual teams themselves, we have lots of them, they have different types of apps, right? And we also try to connect them with others who have similar apps. So it's very much, I would say, a community. And very quickly people get acclimated to it and usually hit the ground running.
Cool. And then the first part of the question, I mean, personally, I've been looking at like server metrics in the public cloud for 3 or 4 years. Really, in the last sort of 6 months, it's become a big issue for the firm. So I think we've started to really look at maturing our whole process in that last, most recent 6 months. So it's still a fairly new and evolving process for us, to be honest, yeah.
I was going to ask about the feedback loop you're kind of mentioning. So how many of the anomalies kind of result in some kind of like governance change or policy change? And kind of follow up to that, have you been kind of tracking over time? Is that resulting in like more anomalies or less anomalies?
Yeah, that's a really good question. So I think that's the hard part. I think I mentioned when it comes to anomaly detection and reporting, it's not so much the detection part, it's the what do you do afterwards part. So tracking the actions to resolve the issue that caused the anomaly, if it was an issue in the first place. That's something that it's up to the individual FinOps teams that we're working with. So again, as Andrew mentioned, we're in the central enablement FinOps world, and then we work with the FinOps teams that are distributed across the firm, of which there are quite a few. They will be the ones that will follow up the application teams and kind of make sure they put safeguards in place to make sure that doesn't happen again. If it's the kind of event that's significant enough that we want to put in place across the entire firm, maybe some sort of guardrails or best practices document, then we roll that out at the platform level, and that becomes kind of baked into the engineering guidance then for everybody as a best practice. Yeah.
Hello.
Does it result in less anomalies over time? Good question. I don't have good data on that.
Hello, Dave Walker, Lockheed Martin. Had a question in regards to your scoring sheet at the beginning there. I saw you kind of had it at a macro level, at an application level with number of services or server host counts underneath. A couple questions I had in regards to this. Do you go a lot further down in your scoring system at a micro level, at a host level, so that you can look for inefficiencies in right sizing or maybe zombie systems that are going to be shut down? And then second part of that is, how do you tackle the non-native memory for like AWS in that, where you're going to have memory intensive systems but no CPU?
Yeah, okay, so the first part, yeah, we do go down to the host level, particularly for the longer running big expensive hosts. Then we'll call out specific examples of hosts that we want application teams to be aware of, right? As you know, it's a highly transient space, lots of instances flowing in and out. You can't really pinpoint one and say, hey, you got to take care of this one, right? So it's more of a theme. So that's the first part. We do get down to that level of detail. We have granular data from, actually we tend to use both Datadog and Dynatrace, and we also have CloudWatch to back up on the metric standpoint there as well. With the Datadog or any other agent that's installed in those boxes, we get both CPU and memory, so we do get both sides of the story there. If it's just native CloudWatch and they haven't installed any agents on the boxes, then we have only got the CPU story there. And we have to we make that clear kind of in our overall reporting, that look, the coverage is not complete here, but it's complete enough to be a good representation of the overall estate, yeah. Hopefully that answers your question. I know that now, like, I think Amazon supports the use of third-party agents, so if you have Dynatrace or Datadog or whatever, you can actually feed that data into CloudWatch as well on the memory standpoint, yeah.
Okay, thank you very much for the presentation, and I have two questions. The first one being, if you have a workload or some specific instances running at a CPU utilization rate of about 30% to 40%, right, for most part of the month, but during some specific periods, you're seeing spikes getting it to about 90%, 100%. So looking at it, like I said, most parts is running about 40%, 50%. It makes sense to actually maybe right-size it to a lower instance type, but sometimes you're seeing this major spike, and when you go to the engineers, right, they tell you that with this spike that you're seeing, it doesn't actually make sense for you to right-size it. So situations like that, how do you handle it? That's the first question. The second question is about, I understand that FinOps is all about us trying to drive down our cost, but oftentimes we talk about not affecting performance as well. So there are instances where I'm looking at an environment, and at the end of the day, you see that some machines are running at CPU utilization rate of 90%, 100%. And you know that the right thing to do is to actually upgrade the instance type to a better one. So, and upgrading it, of course, is going to lead to a jump in price. So is that supposed to still be our scope as FinOps practitioners, or we leave it to the engineers? So. Okay.
All right, so let me try and answer the second part first, and hopefully I'll still remember the first part when I'm done. Okay, so on the second part, I would say that upsizing is part of FinOps to some extent. It's more of an SRE problem, because it'll start to impact the performance of the application overall. Sources like Compute Optimizer will show you when you're both undersized or oversized, and so they'll call out when an instance should be increased in size. On this particular dashboard here, we're obviously focused on optimization and waste, so we're not that interested in calling out when applications should increase in size. To be honest, if you look at the Compute Optimizer report, in our case at least, the vast majority of instances are undersized. There's a fairly small number that are oversized, okay? And then the first part of your question, I think, was around the fact that there are very few simple cases where a host is idle all the time, and so you can call that out as an obvious wastage. There's going to be a lot of variation in let's say, the personality or the operational dynamics of a specific server, and so it's very hard to point to a whole collection of those and make a set of recommendations, right? So the idea with rolling it all up to a dashboard is you're not really looking at individual hosts. You're trying to get total metrics across the entire fleet and give some representation of the overall personality of the fleet, not individual services within them, right? So if you have specific services that have unusual patterns, then you're not too worried about those, right? You're trying to tell the whole story and not individual server stories. Again, we're dealing with literally millions of instances here. We're not that interested in worrying about specific cases. Yeah.
Firstly, thank you so much for that. Some absolutely brilliant ideas. The amount of work that's gone into, both sides, but like the cost anomaly stuff, the amount of data points you're taking to be able to give you so many meaningful points, there's a lot of thought effort, but then engineering time, data engineering time, et cetera, to build that out. My question is kind of twofold. Did you find any challenges in kind of getting approvals for the investment of time and resources to do that? And then what kind of ROI have you seen back on doing it?
All right, well, I can be pretty honest and tell you, it was fairly limited investment because it was me developing it in my spare time, right? So the ROI is infinite because the investment is pretty small, right? So this is literally me working sort of weekends and evenings, and I have a few representatives from my user community here that are always asking for new features, and I'm doing my best to incorporate those, but in reality, it's not part of my core job. Like, as I mentioned, like the job title at the start there, so I'm the lead engineer or head of engineering for Cloud Financial Management, which means I'm supposed to be running 2 engineering teams that are doing other things, right? This is not actually part of our core engineering practice. It's something that we realized was a major gap. It wasn't really on our roadmap, so I just had to figure out a way to try and do it very quickly. So it actually wasn't that intensive. It was done over the course of a couple of months based on some work I had done in a previous role. So in this case, the investment was relatively low. Like I said, identifying anomalies is not mathematically that difficult. It's handling the aftermath, what you do with the communication. And we have a lot of things to do there still around like getting out of the email report world and getting into more SNS notifications, subscriptions, Jira creations, like ServiceNow creations. Like there's a lot we can do in that space, and that's where we're going to evolve into. And that's honestly where I'll probably have to step back and say somebody else is going to have to pick this up and engineer some good solutions on the notification side. Also on the feedback side, so when teams say, hey, look, we know about this, it's all good, I don't want to hear about the alert again. Like normally we would report on an anomaly for a week or so, but what we want to do is get better at incorporating feedback so we can stop those alerts as soon as someone says, this is fine, click a link, make it go away, right? So that's the next part of our evolution as well.
So my question is on can you say more on the compute capacity utilization metric? Like you mentioned, it's a challenge.
Yeah.
Average, max doesn't work.
Right.
Engineering teams will challenge you back saying like, this is not the right way.
It's totally useless as a metric, pretty much, yeah. So what was the question?
So more on compute capacity utilization score?
Like honestly, I could probably do a presentation on compute capacity utilization all by itself, and I'm not sure if anybody wants to sit through that right now. These are like self-confessed anomaly, prefers. So like I think in terms of like the compute capacity thing, we can have a quick chat off stage to the side. I can walk you through some of the terminology that we use there. Yeah.
Okay. Thank you.
But like in a 10-second nutshell, the concept is you figure out for every server like what sort of capacity you consider it to have, consider it horsepower or whatever, and then over the life of that server, you figure out how much of that procured capacity was actually utilized capacity, and you sum that up across the entire fleet, and you come up with a kind of a percentage that's much more representative than simple average CPU or memory. You do the same thing for memory, obviously, as well. And that's much more of a weighted average if you want to think about it that way. You're not doing averages of averages anymore. You're actually taking like sums, totals across the life of every host. Okay.
Thank you.
And then one final question here.
All right, so I'll pick you up on the offer for coming to Dallas meetup for the compute optimization.
Sure.
But is this cloud agnostic?
Yeah, I mean, it is cloud agnostic. None of this is built on native cloud tools, right? So this is all home built based on what we do. I didn't really get into like our whole ingestion process, but we ingest cost data from several sources and consolidate it into a single reporting system for our cloud reporting.
So several cloud data sources or just one cloud?
Right now we have both private and a single public cloud provider, but we will be adding other public cloud providers as well. The point is when you have always multiple clouds coming into a single cost reporting dashboard, then you just have to run anomaly detection one time, right? You don't have to do it across multiple clouds. Yep.
All right. Thank you so much for your presentation. It was super interesting.
Okay, cool.
And thank you.
Thanks for watching. Check out more FinOps X 2024 content on our YouTube channel on the 2024 playlist. Support our channel by liking, subscribing, clicking the notification bell, and by leaving comments and questions for our speakers. We appreciate your support.